Okay, here we go. You're going to take and copy this picture down on the right-hand side. It's going to take us a little while to kind of get to the bigger point of things during today's lesson. And I promise I won't do this every time we need to come up with a new derivative, but this one is classic. Yeah, this is kind of a math major's dream, is to cover this kind of a problem. So what we want to do is we want to prove a trig limit, and we want to use the sandwich theorem. Hey there, buddy. Glad you made it today. An important day. All right. One other thing we're going to add to this picture is we're going to add just a little bit of an arc, okay? Just like that. Okay? Just a little bit of an arc. So the big deal today is that we would like to prove that d over dx, which is another way of writing derivative. The derivative of sine of x is something, and we want to figure out what that something is. And to our disposal, all we have is the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, this will be cumbersome, but it will also be beautiful in the process. Try to see the beauty, okay? So, limit as h goes to 0 of f, if we do f of x plus h, we get sine of x plus h. Minus sine of x all over h. Now, we've done many problems like that before, haven't we? And you notice that everything that doesn't have an h will cancel, and you just, like, good stuff happens. But right now, the fact is if you plug in 0 for h, we end up getting sine of x minus sine of x, which is 0 over 0, and, you know, what the heck is it? You know, how do you cancel off these h's? If I just cancel them off right now, that doesn't really work, does it? And so, fortunately, you had an excellent, excellent trigonometry teacher last year, and taught you this piece, that sine of a plus or minus b is the same as sine of angle A times the cosine of angle B plus or minus the sine of angle B times the cosine of angle A. Remember your sum and difference formulas? Good times. How we miss those days. So, let's expand this a little bit. We have the limit then as h goes to 0 of sine of x times what? I'm going to expand this piece. So I'm going to sine of x times what? Cosine of h. Good. Then what? Plus sine of h, cosine of x, minus sine of x, all over. Sweet. I like it. I like it a lot. Now, in order to make this work out better for us in the long run, I'm going to gather the sine of x's together. So I have the limit as h goes to 0 of sine of x times the cosine of h minus the sine of x all over h. So I brought the minus sine of x over to this guy, and then plus sine of h cosine of x all over h. So all I did is just write it as two fractions. Now I'm going to do one more thing. What can I factor out of the first one? So I'll have sine of x in front, and on top then I'll have cosine of h minus 1 all over h. And then I'm going to take a cosine of x out of the next one. I'll get sine of h over h. Yeah, I know. I always think of that too. Makes me happy. Okay, so let's look at what we did. We were able to expand this a little bit into a shape where this has a certain value, has my h's isolated from the x's. Suppose that this ended up being 2. Then we would have 2 times the sine of x. Suppose this ended up being -1. And we'd have -1 times the cosine of x. We'd like to figure out what those are. And so what do? Since it involves cosine and sine, let's make a triangle. Hey, good thing we already did. We'll call the angle of that triangle. Well, come on, the YouTube people, they're just waiting on it, like building this epic moment where we, make the triangle. It's already done. It's kind of like, well, it's already there. Yeah. There. People watching right now, could you believe how bored they are at home as we're doing this? And I just want them to know the class is focused. Like, they're actually intent. Note, some of them are thinking more about the relationships list that we made and whether or not they're sitting on there. But the fact is that's not as important as what we're doing right now. So, all right, here we go. We have this shape, and what we're going to do is we're going to use this incredible argument. And what's important for you guys to know is this. When I walk in front of the board and I derive a new formula or equation, 95% of the time, I came up with it. Like, it was easy for me to just make happen. This is a different scenario. I don't see where the heck they were able to generate this from. It's way cool, okay? So this is a big idea here. And what we're going to do is, in order to figure out these limits, we are going to represent 3 distinct areas. And the first area we're going to look at is the area for triangle ACE. Does everybody see triangle ACE? And the area for shape number 2 is going to be sector. Sector ACE. What's a sector? Not a vector. All right, I like it. A sector is like a pie-shaped portion of a circle, right? So that would be including then this little sliver right here, okay? And then we finally have one more, and that would be the area of triangle ACD. Now, which is the smallest of those? The second one is actually the middle. The first one's going to be the smallest. Which one's the biggest? The last one, okay? And so we're going to use these 3 shapes, and we're going to end up coming up with sine of h over h and cosine h minus 1. We're going to come up with those. But in order to make this work, it all hinges around this idea of a sandwich theorem. And so we're going to have you flip over a page and write this piece out. What is the sandwich theorem? Well, sandwich theorem says let h of x be greater than or equal to f of x, and let that be greater than or equal to g of x over the interval ab. So this is the really cool part, okay? I've got h of x, which is the top function, and I've got g of x, which is the bottom function, and I've got f, which is the middle function. I know that h is greater than or equal to them for all values over an interval ab, and g is smaller than all of them or equal to over the interval ab. And here's what we know, which is really cool. Now, note that we're dealing with limits. We're doing the limit as h goes to 0. So in this situation, we can state then the limit as x goes to c of h of x is greater than or equal to the limit as x goes to c of f of x, which is greater than or equal to the limit as x goes to c of g of x for all c in the interval ab. No. Nope. What you guys need to memorize for today is very, very small, but I want you to see the complexity of how we come up with this, because especially those of you who are considering going on and taking much more mathematics, these are the type of logical arguments you really want to follow. It's really cool. I'm not going to do this to you guys every month. I mean, we're just going to see this one time and just kind of let it go, okay? So, all right, so the idea is that if h is bigger than everything and g is smaller than everything, then the limit of f must be somewhere between the two. So look at an example. You say, how does this apply? It says find the limit as x goes to 0 of x squared cosine of 1 over x squared. Can you just plug in 0 there? No, that's absurd. And I have no idea what the limit is, for crying out loud. How do they want us to do that? You don't even know what the graph looks like. Well, let's create f of x. F of x is x squared times cosine of 1 over x squared. So I need an h of x. I need something that's bigger than that. You're like, well, how do I just find something? It's really not that bad. Just think about it. Cosine of 1 over x squared. What is the biggest value that cosine can be? 1. So x squared is going to be greater than or equal to that all the time. Wasn't that easy? Well, cosine, the largest value it can be is 1. And so I'll do the same thing again. G of x, what's the smallest, or what is the even less than 0? Negative 1. So I had negative 1 times x squared, which is negative x squared. Because of this x squared right there. So what do you have? Well, let's graph it. What does the blue function look like? What does x squared look like? Parabola. What does negative x squared look like? Well, what are we approaching? 0. So the green function, I don't know what it looks like. Probably looks something like this. Okay. I know that the green function sits between the blue and the red the entire time. Well, let's focus on the blue. What's the limit as x goes to 0 of x squared? 0. What's the limit as x goes to 0 of negative x squared? 0 as well. Well, if f is sitting between those two, what must it be? 0. So the sandwich theorem, or the squeeze theorem, allows us to find very challenging limits through a comparison test. Pretty cool, huh? Now you're like, how does that apply? Well, check this thing out. We're going to squeeze it together. Boom. Yeah. What's my formula for the area of a triangle? 1/2 base times height. Formula for area of a sector. 1/2 r squared theta. That grade trig class you took last year. And what's the formula for area of a triangle again? 1/2 base times height. So let's do this. I want to work in the unit circle. So I want to say that that length is 1. So therefore, this length is also 1. So if this is my center, and then A to C is the radius, and I rotate it, then that would be 1 as well, right? Now, the picture is not drawn very accurately, but okay. Triangle ACE, what's the base? Now I need the height. Well, the height right here, I do know this hypotenuse. Hypotenuse is 1, and the height is the opposite side. So you tell me which trig function has to do with hypotenuse and opposite side? Sine. Namely, the sine of angle H will be equal to the opposite side divided by what is the length of the hypotenuse? 1. So do you agree that this opposite side then is just sine of H? So this height here is going to be sine of h, which is less than or equal to 1/2 times. Now we got to look at the sector area. So what is the radius? 1. What's theta? H. Now look at ACD. 1/2 times what's the length of the base? 1. And now we know this base, or the adjacent side, and we're looking for the opposite side. What has to do with adjacent and opposite? Namely, the tangent of h is going to be equal to the opposite divided by, what is the length of the adjacent side? 1. And so this becomes tangent of h is your height. Anybody else bothered by the fractions? Let's multiply through by 2. We get sine of h is less than or equal to h, which is less than or equal to tangent of h. I like that. And that's going to be something that we can use. Because what we want to end up with is an expression that has a sine of h and an h in it. And we'll get to that. But we'll do it when we get back, because we're at a perfect stopping point right now. Go get some brain food. We'll come on back and finish this up. Okay. Should I put that on YouTube? Okay. Yeah. Oh, can somebody tell me why the 1/2 go away? I multiplied through by 2. Nope. It's multiplied through by 2. What? Now here's the idea. Here's what I want to do. So bring it back to here. We're about like 7 minutes from being done with this piece. But I have an h right here, okay? I also have a sine of h. Now notice what I could do. No. If I divided, I need to come up with this expression. That's the whole idea. If I divided through by h, I would get that expression. But the problem is that I want this thing to be in the middle. So instead of dividing through by h, I'm going to divide through by sine of h. Yep. Now, what's sine of h over h? Or sine of h over sine of h? Is less than h over sine of h. Ooh, tangent over sine. Secant. We need more of that. We need more cheering. Yes. Yeah. Okay. So now, I don't want the sine of h, or I don't want the h over sine of h. I want sine of h over h. So I'm going to take the reciprocal. Do you know what you do when you take the reciprocal? Do you know how you have to do the inequalities? You flip them. And what's the reciprocal of secant? Cosine. Boom. Let the limit go to 0. Let h go to 0. What is the limit as h goes to 0 of 1? 1. Now, what is cosine of 0? 1. Because I don't know that. That's what I'm trying to figure out. So we know that the limit as h goes to 0 of sine of h over h is somewhere between 1 and 1. What do you think it might be? 1. So look at what we just showed. We showed that this value right here is 1. Now all we need to do is we need to do this one. And this one is super short. So let's do the second limit. No, limit is h goes to 0 of cosine of h minus 1 over h. What I'm going to do is I'm going to multiply by the conjugate. Do some Spanish. Okay, if I multiply cosine of h minus 1 times cosine of h plus 1, what do I get? Sweet. Anybody know what cosine squared minus 1 is? Close. Closer the first time. You know you're closer the first time. Oh, gosh. Okay, so let's subtract the 1 over and subtract the sine squared. So we get negative sine squared, right? Okay. We're almost there. Sandwich theorem day. Sorry. Got to know before you enter the door. Maybe. All right, we got our last one. We got the limit as h goes to 0 of. We're going to take out a sign on the top and pair it with an h in the denominator. And then a negative sign on top with a cosine of h plus 1 in the denominator. All I did was separate the fractions, and we are ready to get our second limit. What did we say the limit as h goes to 0 of sine of h over h was? Let's plug in 0 here. What's the cosine of 0? Plus 1. So I get 0 over 2, which is? And 1 times 0 is 0. Sine of 0 is 0. Cosine of 0 is 1. Plus 1 is 2. So I get 1 times 0, which is 0. So that means this is 0. So now we can finish it off. What's 0 times sine? Yes. Yep, just separate it. Yep. What's 0 times sine? So that goes. And what's 1 times cosine? So what did we just show? The derivative of sine is cosine of x. Now that we know that we can, the rest is pretty easy to do. As far as cosecant, secant, tangent, cotangent, all that stuff. But there are two limits. These are what you will have to remember. The limit as h goes to 0 of sine of h over h. It's a very important limit. We use the squeeze theorem to show what it was. What is that limit? 1. And then the limit as h goes to 0 of cosine of h minus 1 all over h is equal to 0. Those two limits are extremely important trigonometric limits that will come up in the future. And later on, you might ask, well, why are those? And I would say, remember the sandwich theorem day? You'd be like, oh, yeah, okay, I guess we did that. Because the sine of 0 is 0. Okay? And so, exactly. Okay, so that's just a nice piece. Hopefully you guys can appreciate the complexity of this and appreciate the approach that some mathematician took to be able to make that proof. So again, I can reduplicate it. I wasn't able to come up with it on my own. I didn't have the foresight to see that piece, but they did. It's pretty cool. And so you have the rest of the hour to work on your study guide. And I believe that the answer key is posted online. If we go to my website, what do you? Oh, get my own domain. Cool. Okay. Maybe somebody already has it. I have to buy them out. Who knows? Yep. Yeah. If you click on finals, and here you go. Here's the final exam study guide key. That's all set for you, okay? So again, that's what you need to be ready to work on tomorrow. We'll do a checkpoint or two, and on Wednesday you have your final. Okay?